Well, good morning, everybody, and welcome back to the CIB Presidential Seminar Series that we broadcast from Purdue University. As you all know, the theme for this semester is Distinguished Women Researchers in the Built Environment. And again, today we have a special treat, and it is our privilege, my privilege, to welcome Dr. Piia Sormunen. She is, let me give a little bit background about Dr. Somyanan. She's, of course, a CIB board member. She currently works at Tampere University, and she has excelled in the field of building technology for over 25 years and is deeply passionate about advancing the field. She serves as the development director at Granlund and holds the position of industrial professor of MEP and energy technology at Tampere University. Throughout her career, spanning more than 2 decades, she has contributed to the development, education, and expertise in building technology, energy efficiency, and lean construction, both in corporate as well as university context. Pia possesses a broad perspective on industry advancements and understands the needs of the business world. Recently, her focus has been on pandemic prevention, indoor air quality, and the development of hybrid energy solutions to ensure a carbon neutral future. Additionally, she plays a crucial role in launching master's level education programs at the Tampere University. Her commitment to innovation and sustainability underscores a significant impact in the field of building technology. Please welcome Professor Sormunen. Pia, over to you.
Thank you, Mark. It's a really pleasure to be part of your this seminar. And today I'm really happy to tell about our research and first a little bit about me more, and also about our research, and also about carbon neutral hybrid energy solutions, what we work with. And start with, have you been in Finland? Who has been in Finland? Raise hand. Mark has been, yes. Just to remind you that Finland is in Europe and in Northern Europe. And as you see, can you see my screen? Yeah, good. Yes. Finland is in Northern Europe, and we have very, very long border with Russia, as you see. And that has been very interesting time recently. You know, all happenings all around the world and in Ukraine. And I have to say, to be happy to be in NATO right now. But everything is okay here in Finland. Everything is going well. We have a new president, and in that way, everything is okay. We are doing well. And something about Finland, we are really land of 1,000 lakes, and that's something what we are really proud of, nature and lakes. And I work really in Tampere University, which is located in quite south of Finland. I'm living in a capital area in Vantaa. But however, I take train quite often to the Tampere and have lectures and research meetings. Yes, as Mark introduced, I'm right now working in Tampere University. I'm working as a position industry professor. It's maybe professor practice. I think maybe you have that kind of position also. But it means that mainly my work is financed by industry partners and companies. And in that way, I'm also working in the private sector in a company called Granlund, which is construction and facility management company. And part of my time I'm working there. So it's a half and half work in Granlund, and half of my time I'm working in university. And that's really interesting because I can follow all the time the sector. how the construction sector is doing and what kind of needs we have in the private sector. And at the same time, I can lead research and give maybe some answers for the business research questions also. And maybe I go a step in my history, but something about me. I have this is my family and my two daughters, 15 and 17 years old, and my very nice cat. It's a secret to my cat, Onti, and my husband. And I love to cross-country skiing in the winter time. You see my skis there, and this is what I do quite often. And overall, I love to go to nature, and we are living just next to this kind of nature area. And in winter time, we have a summer cottage, and we love to go to fishing, and we spend all our summers in the summer cottage. There's one photo of that. Yes, and that's me. And to go into the agenda today, I need to check the time, not going too slow. First, I give a brief presentation about our research team, and I will talk a little bit about EU climate goals, and also what are carbon neutral solutions in buildings, because sometimes carbon neutral solutions is not clear what you mean with that. And finally, I will tell about our project called HYPE, which is a very large project program for hybrid energy solutions and heat pumps. And in the end of after my presentation, you may ask questions, and we may discuss about the issues what you are interested about. But what about we are talking in Finland about building services. What is building services? I think it's more, it might be HVAC systems, it's energy systems, energy production, and also quite a lot indoor air quality, what we do. And in my research team, we are all together right now 7 persons. And mainly I have in my research team postdoc researchers and a couple of project managers. But however, we have altogether 14 persons to be involved this year in our research team. And from civil engineering, some different construction economy and so on. And when I started industry professor position, I was alone. I didn't have a research team. So I have a built research team and applied funding for research team now 3-4 years. And I think it's going well. And what we want to do and what is our scope. As we know, we have very big challenges. One is green transition, and the green and energy transition requires actions in construction and real estate sector. I think it's the same all around the world. Another issue is indoor air quality. As the pandemic showed that it's very important that we have very good indoor air quality. And also the pollutions and outdoor conditions effect on the indoor conditions. In that way, these building services systems has a very big role in having very good indoor air quality. We have these two areas, and we work with the carbon neutral buildings and indoor air quality. And what is the interest in that? The first is the life cycle management, different kind of building services systems. We are interested about construction processes, and how to develop processes and business models so that we will aim carbon neutral buildings and have a good indoor air quality in the same time. And the third thing is the technology. data digitalization in smart buildings. That's very important area, as we know. Right now we have four very big projects going on, and our research portfolio for this year is 1 million euros. It's a $1.1 million or something like that, maybe something. And we do all in very strong collaboration with the construction industry. In all our research projects, there are companies involved in the projects. And the biggest ones is in the pandemic response strategies, E3 projects. You can see the websites. If you're interested, you can visit the websites. And also you can, sorry, my daughter came home. Ei olekaan hiljaa. Yes, sorry, this introduction. And other one is the high projects, which I will tell you later today. And third one is RECO 2 projects, where we develop a concept of smart carbon neutral building blocks. And third one is a bigger program about building services and vision for 2030. So we have lots of work to do this year. Okay, about EU climate goals. And EU has set a goal that we will be carbon neutral in 2050. And it's very, as we know that buildings account for over 30% of all greenhouse gases emissions, and 40% of energy consumption is attributed to the buildings. And in that way, the improving energy efficiency in the building stock is crucial for reducing emissions. The first thing. The other thing is that if we consider in a EU level, 85% of the building stock was constructed before 2001, and estimated 85 to 95 of these buildings will be still used in 2050. Lots of work to do. And we know that existing buildings are not energy efficiency, and energy production is heavily relies on fossil fuels. And we have had energy crisis in Europe because of the Russian gas, and we don't get it anymore. And yes, lots of work to do in existing building stock and renovations. And what is happening now? We understand and we trust that the future energy system will be relying on renewable energy sources, and it makes us we need to work with the processes, technology, and also business models to achieve that. And electrification, it takes a big role, and especially heat pumps, to using heat pumps in different purposes, to capturing waste heat, recycling energy, to using energy storages. It's a very important part of in energy transition. And heat pumps' role will be more and more important in the future. But it means that we need more research, we need more education in that area, and we need more designers, construction sector to understand different kind of technologies, and especially these hybrid energy solutions. And in that way, it's very important area to work with, and one of our main areas in Tampere. And about the hybrid energy solutions in buildings, what it means. Again, I showed you this building services system picture, and energy sources, energy production. This is very typical in Finland. We have a district heating system, and in a building we have a boiler, and we have a heating for space heating and heating for ventilation systems, and so on. And also we quite often in the big cities we have also district cooling systems, what we can utilize for cooling ventilation, for example. And in hybrid energy solution, we talk about energy production, how to produce, how to have energy production and renewable energy, and what kind of systems we can use. And in a hybrid energy solution, we understand in a hybrid energy system, it's a system with several parallel energy generation means. It means heat pumps, heat sources from ground, air, waste heat, and even water. It means different kind of boilers, oil, gas, wood, pellet, electrical boilers. It means solar energy, thermal solar energy, photovoltaic energy, and also it means discrete heating systems. And how we combine these different energy sources to get the optimized system solutions for the building. And because sometimes it's good to combine, for example, a ground source heat pump with a discrete heating system. And in that way, it's a very important part of in a design phase to consider what kind of systems are optimal from energy efficiency point of view, in a carbon emission point of view, and also economical point of view, financial point of view. And this shows, it's in Finnish, but it shows the heat power if on the system. For example, in this building it used district heating in the peak hours. It used also air water heat pump, and also it recirculates energy. And when consider energy efficiency in the buildings, we have three levels. I will not go into deep in these different possibilities, but however, the first level is that, of course, avoiding consumption. This is something what everybody we can influence on, and how we use buildings, and how we use electricity, what kind of room temperature we have in a building, and so on. The second level is that we can utilize more efficient systems, and also, for example, to use heat recovery systems, taking heat recovery from the exhaust air, heat recovery from the sewage water, and so on. And the third level is that what kind of energy production we have. So we divide it in a consumption, how minimize consumption, and what kind of technical systems we have to get a very low energy consumption building. But however, we have to consider what is the energy production systems what we use in buildings, and that's the optimization task. And heat pumps, I will go a little bit the different technologies here. And overall, the heat pumps, I think it's very clear, all of you, that it's like a fridge, but it works opposite. And we can utilize heat, we can transfer heat from from the lower temperature to the higher temperature. And the heat source can be ground, for example, boreholes. It can be air, or it can be in a recirculated waste heat, for example, from for supermarket or industry. But we can use heat pumps to get from the lower temperature level to higher temperature level to utilize that. And it's very important. And it will it's a very important way to get a very efficiently produced energy. And as you know that overall it's working with electricity. It's kind of electricity heating or electricity cooling. And we have here I have 1, 2, 3, 5 different kind of heat pump systems what are used in Finland nowadays. The first one is air-to-air heat pumps. It's mainly used if you want to cool down your house, or in wintertime to heat house with the air. Very clear. And so it's a weather dependence, the power. The other one is an air-to-water heat pump. For example, my house, we have the primary heating system is air-to-water heat pump. So we use air heat pump to get in the heat from the lower temperature air to the higher temperature water system, and it's working well. But in that way, we need to have a secondary heating systems, and we have a fireplaces, what we can use in case there are problems with electricity. Third one is exhaust air heat pumps. It's mainly used in residential buildings. So you take waste heat from the exhaust air, and that's quite often used in the new residential buildings. And the ground source heat pumps, where you use the energy wells, boreholes for the as an energy source, and ground source heat pumps are mainly used in office buildings, multi-purpose buildings, even nowadays in a city area, because we can use very deep chill holes, and it's becoming more popular nowadays. And free cooling, of course, we use in when we have a ventilation system. Maybe I don't go very deep in these different system types, but you will get my slides later if you are interested about this technology. And of course, when we design different hybrid energy solutions, systems, it's very important to take account climate conditions, because it's influenced quite a lot the system. And for example, if we consider Finland, we have very, if we consider, for example, solar radiation, we have quite a little solar radiation insulation in wintertime, but quite a lot in summertime. And in Spain, for example, of course, it's they have more also in summertime, and German is somewhere between. And this limits, for example, solar energy systems, utilization of the systems, because in the winter time is about 5 to 10% of the summertime generation. So we can take account this yearly seasonal variability when we design systems. And here are also some solar energy figures. As you see, it's very little. It's very little sun and very little light in the winter time, so it influences a lot. And solar thermal systems, that's the same. That's why this seasonal difference, we don't have so much solar thermal systems because it's limited also only in summertime. And in the summertime, we can use that mainly for hot water. And in that way, it's not, it's of course it's working well, but however, it's a, it's a, it's the cost efficient is not so good in these systems in Finland, what is in a southern Europe or in the southern areas. But solar electricity is very popular nowadays, and we have a grid connected and off-grid connected systems, and these grid connected systems are most common right nowadays. But I have to say that also the housing they are using more and more off-grid standalone systems, and it's I have to say it's working well also in on site. It's getting more and more popular. As you see, I think you have quite a lot solar PV panels in your area, and but I think it's more coming to Finland because our Nordic situation, level Nordic situation of the country, and in that way, we are now focusing on more and more PV panels. And seasonal energy systems, not so much used, but still we are doing quite a lot of research in that area, how we can utilize for thermal energy storages. And boreholes, of course, in the systems are very important. And as I mentioned, that this very deep geo boreholes are coming, and we are planning to start research in that area also, in the city area, and that will be very interesting. And some examples of the buildings with a hybrid energy systems. Here is one building, the car building, dig air building, which got this kind of heat pump award. And this building used heat pumps in many heat sources, ground heat, sewage from a building, rotary store, refrigeration, waste heat, and also it takes for the cooling grid of the building. And it's integrated with the district heating so that we have a backup or this building has a backup from a district heating in certain situations. And it has 16 boreholes for heat storage and also used for seasonal storage, and using also free cooling in a certain time of the year. And also the building has solar panels. And so total heat pump capacity was 115 kilowatts, and COP 3.2. That's very good. And the cooling capacity 100 kilowatts and COP 4.9. So it means that it's certified in lower than 25 kilowatt hours per square meter per case energy. Very good. And very widely used different kind of heat pump heat sources. And other example is about energy renovations. It's a building with 54 apartments, and built in 1980. And there were this kind of renovation program in this building. And in the first phase, the energy renovations included, for example, new doors, windows, new radiators, valves, and thermostats, heat distribution calibration, and also balcony glazing that's very popular in Finland, and you have it because of the climate conditions. And next year or next phase, the new carriage doors and were installed, and insulation was improved. New windows for commercial section was installed, LED lighting and pressure limiters on water taps and so on. And also heat pump, now I have to say, yes, heat pump production and solar thermal energy, yes, in that case, even in solar thermal, 10 square meters. And finally, in the third phase, they installed 5 boreholes, 300 meters deep, and installed sewage heat recovery and solar electricity, and installed decentralized cooling and also electric boiler as the peak loads. And also they have two-way district heating selling system and EV charge points. So it meant that they could come really much down with the purchased energy consumption from 2010, and it was from 44 to finally to 5.6. And of course, if you consider all these systems as renovations, it has cost quite a lot of money. And this project was done with the EU grants to test it and to see how low the low energy consumption we can come down with a different kind of heat pump technology and different energy renovations. And it shows that it's really possible. But sometimes it comes to a limit. What is economical feasible? And in that way, always, even it's a renovation and considering different kind of hybrid energy systems, it's good to consider what is optimal solution for that purpose and for that building type. And here is a very, very messy, maybe, picture about hybrid system monitoring screen. I wanted to show that because it's very important that when we have a hybrid system, for example, we have here solar thermal collectors, we can follow energy production and also temperatures and pumps and so on, pressures. We can follow PV panels production. We can follow ground source heat pumps production. We can follow also cooling system. We can follow altogether ventilation, heat recovery, sewage heat recovery. And that's very important because it's very important that the system is working properly. And as we understand that more we have different kind of technologies and systems, it's always possible that the building is not working as designed, as constructed. And in that way, the facility management has a very big role in follow up that the building is working properly. And this is something what we need to work with, and this is something what we wanted to also work with in this hype project. Yes, I don't have much time anymore, so I will go very fast. And And in this project, we are concentrating on the construction processes, building energy management, and real estate business, different kind of areas. And the main goal is to eliminate carbon emissions and achieve a sustainable energy efficiency. And how to do that? We want to focus on lean construction, we want to focus on energy management, and we want to focus on from the real estate business point of view. Different, not just processes, technology, and also business, facility, investors point of view. And taking account through the life cycle of the project from project definition to demolition. And this project works so that we have every year 3 different research sprints, and each sprint will last 10 months. And a steering group of this project will decide every year these research sprints. And in the steering group, we have 5, 6 companies and also research lead. In that way, we are focusing on certain areas which are very important to the private sector. Is it designer, or is it a property owner, or is it a technology heat pump provider point of view? And we have also right now one doctoral thesis going on, and there will be 2 more in this area in working with the research team. And every year we complete after 10 months. It's very, very quickly. We want to get the results very quickly, going in, of course, doing the going the deep, but also to get results quite soon. And so far we have had 3 research sprints, and 3 are still going on. And the first one in last year was energy efficient building project delivery, and we wanted to study different challenges what we have in construction. And we notice different challenges. You may get visit to a website to see, and also we try to find solutions how to solve the problems in that in a building process. It was both a new construction and also building renovations work, and the main project manager was Sina Moradi. I think you, Mark, know, and Sina was leading these projects. Very interesting, I understand. And finally, we developed a collaborative project delivery model, how to take care of this sustainable building construction, and we are continuing with that. Other one was a hybrid energy system tool, and it was used for optimizing different systems. And hybrid system, as I mentioned, that it's very important to optimize. And this tool takes account existing. If we consider renovation, we take account the real consumption data, what is right now. And according that, we can optimize the best hybrid energy solutions for the building and analyze the results with this tool. Very easy use tool, very good. And third research sprint was real estate owner for real estate owner and about regulations. It's a huge amount of different regulations in EU right now, and we need to understand what it means. Is it in a taxonomy, EU climate law, and we have a certain program called Fit for 55. Important to understand. And right now we are working with different collaborative delivery models in sustainable construction projects and risk management of building energy renovations, and also solutions for area-based energy production. And this is the research sprint what we do this year. Next year, and 3 other ones. It's a good way to work in with the companies. And if you are interested about these results, you can find all the journal articles and conference papers on that website. And overall, you get all the information about the projects. And now I want to thank you. And if you have any questions, I'm really happy answer now or later.
Professor Sormunen, that was a very interesting presentation. And let me open the floor for questions. If you have any question, please open your mic and ask directly. So while people are thinking about their questions, let me ask one of my questions that I had. You talked about different energy sources that are being used, and I was wondering which one do you think is predominantly being used in Finland?
Yes, if I think residential buildings, housing, it's air-to-air heat pumps, mainly used, quite low-cost systems. And but when we consider, for example, office buildings, it's a ground source heat pumps. It's mainly used systems. But it, of course, depends on a little bit the building type, what kind of building type you have. But also in the housing, residential buildings, this I would take this these air water heat pumps are getting more and more. Air water heat pumps are getting more and more popular, especially in new buildings, new houses.
So
what about there in US? What do you think in housing? Do you use heat pumps?
I will defer that question to Professor Widener.
Okay. Yes.
Yeah.
I'm sorry.
Yes. Okay, it came very fast, my question. It's your time to ask me questions. I started to ask you.
Sorry,
yes.
Ted, didn't mean to put you on the spot.
Yes.
So my question was going to be that, among these 5 different heat pumps, which one gives the most efficiency in the environment that you are?
Overall, the ground source heat pumps are the best ones because it's not so much independent of the weather conditions. Because air to air, we are always dependent of the weather conditions, and it affects on the COP of the system. So I would say that ground source heat pumps are with the best energy efficiency energy efficiency.
Well, let me open the floor again for questions from the audience.
Thank you for your presentation. You somehow answered my question as Professor Hashtag asked you, but I wanted to make sure when you are considering different types of heat pumps available, how do you determine the most suitable heat pump system for a specific building or in a specific location? Or what are the key factors that impact or influence that decision to choose one type of heat pump over another in your projects?
Yes. Yeah. Yes, as I mentioned that it's a very important optimization task in a design process. Is it new construction or renovation? And there are a couple of things which influence on the choice of heat pump types. One is the building type. What is the energy consumption profile of the building. And another one is location, because sometimes it's if you are in very dense city area, ground source heat pumps are not possible to use because maybe there are something underground infrastructure there. It influences, and in that way, it's also. It depends also in Finland, is it district heating and cooling available? That's also one thing, because district heating, for example, is just available in the big cities. It's not available in countryside. That's also one thing. Because in district heating and cooling systems are very good in Finland, and the energy price is quite low in these systems. So in that way, it's one criteria also what is economically feasible. So it depends on different factors and has to be taken account when starting the project and setting target for the construction project.
Thank you
I
so
hope
much.
that answered your question
Yes,
somehow.
yes. Thank you so much.
Thank you, Manoj. That was a good question. Anybody else? Just please open your mic and ask your question directly.
Yeah, I have a question.
Yes, Majid, go ahead, please.
Yeah, can you talk about like this system has like different components and the price might vary from one to another. From the user perspective, I mean, prices influence the user to like which one to pick. So can you talk about their prices? Which one is the most expensive and which one is the cheapest, and how efficiency differ with their prices?
Yeah. You mean heat pumps overall? Heat pumps or different systems?
Heat pumps.
Heat pumps, yes. Air-to-air heat pumps are quite reasonable price, and it's quite a lot used. And it's for example, in our house we installed air-to-air heat pump. It was something like 3,000 euros, the whole system. And in that way, it's a quite reasonable price. And if we consider then the air-to-water heat pumps, it's a little bit more expensive, but less expensive than ground source heat pump. Because in ground source heat pumps, you need to drill the boreholes, and that's quite expensive. But many times, in a life cycle perspective, you will get back this investment cost. And the exhaust air heat pumps, I think they are something same as air-to-water heat pumps. So would say that the cheapest one is air-to-air, and the most expensive one is the ground source heat pumps, or whole system with boreholes.
So, given, let me follow up on what Majid asked earlier. That given that in Finland it gets quite cold compared to us, for instance.
Yeah.
What is the efficiency of the ground source heat pumps, and how deep do the boreholes need to go to really make it optimal?
Yes. Yes, this is a good question. The boreholes, my understanding is that we go to 200 to 300 meters. And normally before they start a project, they do this kind of test drilling to see what is the ground heat capacity, how to say. And in that way, it depends on how deep boreholes you need to drill. And that's the best way how to do that. But in Finland, we are testing right now very deep, like 2 kilometers, boreholes. And in that way, you don't need so many. You can have only 1 or 2, and to use the ground heat for heating or cooling.
And what is the transmission source for the boreholes in terms of heat transmission?
It's a water.
Water-based. Okay.
Water-based. But now I'm living. It is not exactly my area. So, but if you are interested about, you may send me questions. I can now talk with my research team.
Yeah, certainly. Yeah. No, thank you.
Exact technology.
Well, let me open the floor again. Questions, please.
Hi, thank you so much for the very interesting presentation. I was just wondering about the life expectancy of these heat pumps. You touched base on, many aspects of it, but, how long do you think, or the maintenance part of these,
Yeah.
Maintenance, and thank you so much. I really enjoyed the presentation.
Okay, thank you. Yes, that's very important to have a maintenance and overall lifetime for the pumps is something, my understanding, something 15 years, depending on the pumps. But however, of yearly maintenance is very important, and to have a program for maintenance. And exactly this, I'm not so familiar with really exact maintenance program, but however, it's a very important part. And as I showed this monitoring systems, it's very important for the facility management to follow how the system is working and react directly if they see some problems in the systems. And it's very important part. I hope that answers somehow.
Yes, thank you so much. Thank you. Thank you. Really interesting.
Yeah.
Thank you.
Thank you.
Thank you, Professor Alumadi. That was very nice question. Let's move on again. See any other questions coming up.
I have a question.
Yes, Matt, go ahead, please.
You mentioned in the slides that Europe is planning to be carbon neutral by 2050. Do you think they are on a track to achieve that? If not, what needs to be done to get back on track?
Yes, it's a very, very big task for everyone, and somehow I think right now in the EU, different countries, they have their own programs for carbon neutral cities and carbon neutral country, and we are doing quite a lot of work with that. But one thing what I'm worried about is these old building stock. What we can do for that? As I mentioned that we have a quite big mass of the buildings which are built before 2001, and what we need to do to get this building mass renovated and to get energy efficiency in a right level to achieve the carbon neutral level. Of course, in a new construction, it's quite easy because we can influence on design solutions quite well. And this carbon neutrality, it means also construction materials, carbon or embodied carbon emissions in the construction materials, not just the energy. But we know that energy is one very big part of the carbon emissions. But of course, the materials plays very big role. So my trust is that we are going to do that, but we have to do quite a lot of work with that.
Thank you, Majid. Any other questions?
No?
Well, I had a couple of questions. I understand that in Finland and Sweden and around that region, number of data centers are coming up, and because of the low cost of cooling.
Yeah.
But my question, maybe this is off the cuff here, but uh, I mean those data centers generate a whole lot of energy or heat rather. Is there anything being done to capture that heat?
Yeah. Yes, we are doing quite a lot of work with the capturing heat, and quite often the data centers are located just next to a certain communities or where we can utilize the recirculate heat. And that's very important issue, or not just blow the heat to the air or to the water, to the sea or lakes. And it's very important part of the in a communal places design how to utilize that waste heat.
Well,
And yeah.
Sorry, go ahead, please.
Yes, I was just saying that, of course, we have some examples, but unfortunately, I don't have here about these examples.
Well, let me open again. Any pressing questions from the audience? Please open your mic and ask your question. Well, not hearing any. Let me ask my last question then. And so this is very interesting. A lot of questions coming to my mind. But in the interest of time, let me just ask one more. And that is that you mentioned that there are a number of buildings in the country that were built in 1981 or before that, and you shared one of the projects that was being used. But my question was that is there a concerted effort in the country to renovate these old buildings, given the 2050 goal? And is it the government, or I mean, you mentioned EU and Finnish sources, but was that only for that project, or is the government actually helping renovate most of these old buildings, or are people getting to pay for it?
Yeah. Yes, we have some support actions from the government for the renovations projects, especially if there are the renovations for energy efficiency of the buildings. It's possible to apply the special funding for that to get a part of the renovation costs to be paid with that funding. And this is some support actions what we have right now, especially with energy efficiency, to improve energy efficiency.
But is there a requirement from the government that people should comply, the owners, and renovate the buildings by a certain period of time or something, or?
Not exactly, but I have to, yes, because now it's coming new EU regulations and building codes, and there are some requirements for the energy class of the buildings. And in that way, it means that you have some requirements to do actions also to the old buildings. but it means that you have to come up a couple of classes up with the certain building types. Yeah,
Okay.
that's right. Yes, it's coming from to the building codes in that way.
Okay. Great. Well, thank you very much. This was really very exciting topic, and thank you for taking time for making the presentation. Really appreciate that. So please open all your mics and give her a big round of applause.
Thank you. I'm really
Thank you very
happy.
much.
I'm really happy to participate this seminar and happy to share my research area results and experiences. Thank you very much.
Great job.
And-
Looking
and-
forward to seeing you here. Go ahead.
And please
Thank you.
share your PowerPoint
Yeah,
presentation.
I will share.
Yeah,
Yes,
thank you.
I will share. Okay,
Okay,
thank
thank
you.
you.
Great.
Bye,
Thank you very
everybody.
much.
Thank you.
Bye-bye.
Bye-bye.
Thank you. Bye.